Have you ever wondered why Venus and Mars do not have life if they are both in the habitable zone? Humanity has ever been fascinated with the possibility of other worlds containing living organisms. While our visits to the Moon revealed that it's completely barren and deserted, other Earth-like worlds in our solar system, such as Venus and Mars, have left us with many questions. Just before we address this, there are a few things you need to know. First, what does a habitable zone mean? In astronomy, the term habitable zone refers to a region of a stellar system, a range of orbits around a star with ideal conditions that allow for the existence of life. The idea is simple. For life to thrive in a region or atmosphere, it needs liquid water and appropriate temperatures, among other indispensable factors. Now that you understand what a habitable zone is, then which planets are in the habitable zone of our Sun? Our solar system consists of 8 planets, and each planet is unique. However, the 8 planets can be grouped into 2 distinct categories: the inner rocky planets, Mercury, Venus, Earth, and Mars, and the outer gas giants, Jupiter, Saturn, Uranus, and Neptune. In our solar system, the habitable zone is situated between Venus and Mars. Located within that region is also our planet Earth. Mercury is outright out of the habitable zone, and Venus is just at the borderline into the habitable zone. Mercury and Venus are too close to the Sun to sustain liquid water for long. Venus is barely in the habitable zone, and the same is true for Mars. Because of the elliptical orbit of Mars, which is due to the gravity of Jupiter and the other gas giants, Mars enters and leaves the habitable zone at different points during the Martian year. Which leads me to the next thing you need to know. That an element or planet is located in or around this zone does not necessarily imply that it can develop and harbour life. In simple words, the fact that a planet is in a habitable zone does not automatically make it habitable. Of course, graduating from Harvard University does not guarantee that you'll be successful or become a millionaire. So, technically, Earth is the only planet in our solar system's habitable zone that is habitable. Then what does a planet need to be considered habitable? It must not be too hot or too cold, and it must be of sufficient temperature to hold liquid water. To sustain metabolic activity or even living beings, the element must have some source of energy, starlight, internal heat, or chemical energy, at least for billions of years, thus allowing life to emerge and develop. Fun fact, the presence or evidence of water is not the only criterion that makes a planet habitable. A planetary body can be far outside the habitable zone and still harbour liquid water. Have you heard of Jupiter's moon, Europa? Underneath its icy outer crust is a liquid ocean that contains more than twice the amount of water on Earth, even though Europa is extremely smaller than our own planet. This is probably why Earth is so unique and maybe one in a billion planets existing in the cosmos. So many factors helped us out: plate tectonics, the core that produces a strong magnetosphere, a big moon, apt temperature, and so many more. According to historians, there is evidence that suggests that the Sun used to be much dimmer and that Venus had oceans, but its closeness to the increasingly brightening Sun caused the liquid water to evaporate. This evaporation might have been the cause of the planet's current, inhospitable, dense atmosphere. Mars also once had flowing liquid water. Many of our space missions have found evidence of ancient lakes and minerals that carried components of water. In fact, in 2018, scientists found evidence of a subsurface lake. All this is evidence from the past. Currently, liquid water is no longer present on these planets. This leaves us with the question, could there have been life on these planets billions of years ago? Remember, the Earth we know today never used to be like this 5 billion years ago. During that time, our planet was characterized by a partially molten surface, volcanism, and asteroid impacts. Several elements made the newly forming Earth incredibly hot and hostile to life. Of course, any civilization existing then would have proved beyond doubt that our planet could not harbor life. But here we are today. It's scary to think there are other living beings in the universe, but it's even scarier to think we are the only living beings in the universe. If you could travel back in time to the initial stages of the solar system, going by the characteristics of our planet Earth, you would not only find one life-friendly world, but 3: Venus, Earth, and Mars. All looked remarkably similar. They all had substantial surface gravity and atmospheres similar to each other. There were volcanoes, watery oceans, and complex interactions, that enabled these worlds to retain the heat they absorbed from the sun. Moreover, the compositions of their atmosphere were similar, all rich in methane, nitrogen, hydrogen, ammonia, and water vapor. It could be said that there were favorable conditions to support life springing up in all three worlds. But something unfortunate happened. There were hypotheses surrounding the incident, but no one knows exactly what happened except for the aftermath effect. Venus experienced a runaway greenhouse effect, boiling its oceans after perhaps 200 million years, but Mars lasted far longer before becoming inhospitable, over 1 billion years. Both Earth and Mars likely experienced catastrophic early collisions that led to the creation of Earth's moon and Mars's 3 moons. Yes, rather than the 2 moons we see now. Mars once had 3. However, the largest moon fell back to Mars, and only 2 remain visible to this day. It's remarkable that these planets, which might have had similar histories in their early stages, have become 3 distinct and incomparable elements. All 3 worlds have now been shaped by external impacts and internal geologic processes. Let's get back to the present-day Venus and Mars. There are quite a few factors that oppose the sustenance of life on these planets. Let's examine a few of them. 1. Another reason Venus does not have life is that it does not rotate. A Venus day is longer than a Venus year. Okay, let me break that down. Venus rotates very slowly on its axis. 1 day on Venus lasts 243 Earth days. However, the planet orbits the Sun faster than the Earth. Earth orbits the Sun in 365 days, which makes it a year. But Venus takes only about 225 Earth days, making a Venusian day longer than its year. While Mars has an erratic rotation, there has to be a stable rotation to harbor life. Approximately 24 hours, more or less, in duration. It can be 22, 23, 28, 36 hours, just as long as it's stable, dissipates heat, and can be grouped into seasons. 2. Venus is known for its crushingly high air pressure, incredibly thick atmosphere, and surface temperatures that are hot enough to melt lead. In other words, it has some of the most inhospitable surface conditions in the entire solar system. Mars, on the other hand, has almost no atmosphere. This lack of an atmosphere causes very cold and fluctuating temperatures. Mars also lacks a magnetosphere. However, during the summer, temperatures on Mars's equator can reach 20 degrees Celsius, and wintertime temperatures plunge to minus 153 degrees Celsius or minus 225 degrees Fahrenheit. 3. Mars has Marsquakes due to some seismic activities on the planet. The cause is unknown and quite different from the cause of earthquakes on Earth. 4. The atmosphere on Venus and Mars constitutes about 95 to 97% carbon dioxide. Life cannot exist in such an atmosphere. Besides, Mars's surface is constantly being bombarded with ionizing radiation, and its soil is extremely rich in perchlorates, which are poisonous to microorganisms. Is there any possibility that Venus and Mars could harbor life in the future? With Venus's extreme surface temperatures reaching nearly 462 degrees Celsius or 863 degrees Fahrenheit, and the atmospheric pressure 92 times that of Earth, the possibility of water-based life surviving on this planet is almost an impossible phenomenon. But the possibility of microbial-level life on Mars has still not been excluded. A plethora of evidence has pointed to the plausibility of life on Mars, not only in the ancient past, but maybe even now, which could as well evolve in the nearest future, just like Earth. The general view of life existing or ever existed on Mars could be found intact in the subsurface, away from the harsh surface it has today. But since we are yet to innovate the technology to explore the inner core of other planets, we are compelled to work with our speculations. See you next time.